Better than 1,000 words, unless it's mine. Sometimes the words are better with me. Looking at this presentation, the class summary, this will not be a pick and click class. I'm not going to run through nuts and bolts of Revit features and steps. For plumbing, I want to look at a big picture and what makes plumbing coordination work and what are some of the learning objectives. So describing the three major elements in team collaboration, understanding level of development, defining key elements that should go into project general notes and specifications, use Revit MEP for 2D documentation, and knowing the keys to successful coordination. Really quick about our firm. We began in 2003. My wife started the company. We have three main areas. We do virtual design and construction with BIM implementation. We also do that technology implementation for owners, contractors, design firms. And additionally, we work in the areas of MEP, structure, energy enclosures, and civil. What distinguishes our group is we work both construction and design side. I work in the leadership group of the AGC BIM Forum, and I'm also working on the co-chair of the Structural Engineering Institute's National BIM Committee. So we're going to talk about this topic from a couple of viewpoints. And our groups work with a few other committees. As I begin here, again, we're going to try to do the Cliff Notes in the 30-minute slot and expand from there. So these are some of our top 10 lists for plumbing. We feel like a lot of projects go off just in the communication and have a BIM execution plan and have it written. There's three big items we find when we start to coordinate plumbing. It's the coordinates, the naming convention, and the level of development. We feel like these are three foundational things that have to be clear amongst the team. We feel like a good coordination with plumbing starts with a good structural model. And I'm going to visit here and talk about sleeving structure and what to think about and how to ask about it. If you're focused on getting your plumbing in, looking at a collaborative approach on clearing the above ceiling spaces. Making the wedding cake diagram, I will explain this in a moment. Thinking through long sloping runs with structure. So I'm going to talk in particular, if you're a designer, thinking about, you may not have in your scope to fully model manufacturing level of development of your elements throughout your project, but at least think through your long runs and how those will fit in the space. Some things to know about laser scanning that are very germane to plumbing and how it fits with structure. Duct is typically cheaper to modify than fittings, and I'll dig into that as far as plumbing fittings. I'm talking about large bore piping. When I think about these, I want to ask real quickly, about half of you were in the session I just finished, which was on 3D coordination. These are similar topics. I'm going to probably go through the slides that I predominantly had in the last presentation towards the end of this one. So you may see me fast forwarding some, and that's just in the interest of time. How many of you are working for design firms, pure design firms that do mechanical design? Okay, excellent. Are there any architects in the room? Okay, couple. Are there any structural engineers? One, okay, very good. I don't want to put you on the spot too much. Is you're a multidiscipline firm? Excellent. And what would bring a structural engineer to a session on plumbing? Excellent. BIM manager. Very good. How many BIM managers do we have in the room? Very good. Interesting. Of those BIM managers, how many of you come from a structural background? Okay. Ironically, I go around and I see a lot of them come from that background. Interesting anecdotal parts. Are there any building owners with us? Okay, one. What type of projects? Healthcare, university? University, very good. Okay. So do you deal with facility management or planning and construction? Planning and construction. Excellent. Okay, very good. So I'm going to talk about some things that might go into RFPs things to think about from an owner's perspective. Are there any attorneys in the room? Oh, good. We can speak freely then. But I'm going to talk about standard of care of the profession and perhaps things that would be involved with risk and scope and contractual language. We'll just talk about those. So first off, this was a key point, have a BIM execution plan. And this is something that's very personal to every firm. I'm going to talk about some basics that go into it if you're looking at plumbing in particular. I'm going to talk about a level of development. And some of the work I do with the AGC BIM Forum is I'm working on a committee right now that's working on a graphical guide for level of development. David, who's in the audience here, he's also on that committee. And so when we get to the Q&A, I'd be open to visiting on the topic in a kind of an open forum here. Essentially, who has not heard of the E202? Okay, some. Very good. I'm going to give you a quick elevator synopsis of it. Essentially, it is a document that would define the level of development of an object in a model from 100 to 500. And traditionally, we've had 1, 2, 3, 4, and 500 levels. I'm going to talk about maybe the concept of an importance of adding something in between 300, but let me quickly go through those. And this is all background stuff as we dig into plumbing in particular. At a 100 level, a model element may not be actually modeled. At LOD 100, you might have a mass model from the architect and a narrative on plumbing. And it would talk about what kind of systems might be used. At 200, you'd have generic system objects and assemblies with approximate quantities, size, shape, location, orientation. At 300 is when those objects would start to have specific assemblies and accurate in terms of quantity, shape, location, orientation. I think this is important because you don't have an LOD of the whole model. If you have a plumbing model, you're going to have a cocktail. Some elements might be at 300, others at 200. If you had early on modeling and all your gravity lines are flat, you cannot say that those pipe elements and plumbing elements are at 300. They're at they're something less. They would be at 200. One of the things the committee is looking at right now would be, is there a known step that needs to happen, a known use in between when an element has a design intent level information but yet short of total fabrication? And I'd submit to you that perhaps there's this level in between that needs to happen. So we can discuss that. So at 300, I'm saying that is when you would, 350 is when you'd have cross-trade coordination. Once an element gets to a certain point, is there information that only a trade would have? Now, if you're working in a design build firm, you'll have these lines get blurry. If you're working in a hard bid environment, they're a little more clear. Yes, sir. Everything. So a fitting, a pipe, any element within the model. Right now we're talking kind of broad scope right now. So we haven't drilled into Revit specifically here. Okay. How many of you are working on hard bid projects? Okay. Versus, how many are you doing integrated jobs in the sense of design build, design assist? Okay. Very good. How many of y'all are not finding a lot of jobs at all? I didn't see everyone. There's an imbalance of hands here. So hard bid or integrated. So we won't answer this third question. The need for this intermediate step of cross-trade coordination gets blurry if you move into a design build and you're bringing on trade level information early on. And that's where we're going to talk about, maybe instead of having a spec that has generic equipment, you could actually get detailed about exact equipment and then talk about where fittings connect to. And then having those modeled at a higher level of detail. 400 is fabrication level, 500 is as built in place. In the interest of this first half, we're going to move forward. Essentially, each assembly would have levels of development it would progress along, and there will be different use cases. So you could look at estimating, and early on would it be lengths of material and fitting counts, and then also attributing labor to it. But then another use case would be 3D coordination, and then you could get into process layout and planning. So now I'm going to move into some examples, and these are just to give you a feel. If you look at roofs, you would have, this would be an example of a roof at 200 with structure at 100, and you might have a structural narrative that would have gone along with this level of model. In a traditional delivery method, this might be schematic. Documentation was made from this model. As it progresses along, in a traditional delivery design development, you might find elements nominally at 200. And then as you progress to where the elements are at 300, these are the bar joists. As you might have heard us mention in the last presentation, if you were in it, these bar joists are a manufactured product. You can't run your plumbing within that bar joist space until you know the exact web profile from the manufacturer. So you could get a designer's model, but it's really eye candy if you want to run your systems up in the level of the bar joist. Now, if you just need to know depth and slope, and you want to run your plumbing below, then the model's good for that, but to actually go in it. When you start to look at the model where you have fritted glass versus clear spandrel glass, that'll start to affect what of your plumbing is actually showing through on the outside of the building. What considerations you have to give about what's visible. And is the glass, that's supposed to be fritted and frosted really done that way? So then you would start to need that curtain wall in an LOD 300. Wood framing, I'm not going to focus a lot on this. We have another session on Thursday that dives heavily into multi-unit wood. But you're starting to have tools out there within the Autodesk products and add-on products such as Vision Res that will do highly detailed wood framing, where you have floor trusses, roof trusses that are the manufacturer's trusses with web profiles, and you can actually start to do detailed pre-manufacturing of sections of plumbing. And then also just doing the coordination. Therein lies the challenge, are there enough trades within the markets that work on wood projects that could handle these things? But there are projects right now we're working on where the walls are panelized and are pre-drilled for the plumbing and electrical conduits. So this is kind of a new frontier, but you need a level of development dialogue to get there. So just in summary, if you had structural model and you're trying to look at where, say, plumbing coming down would be turning out, your design elements at 300 wouldn't really get you there. You would need trade level information for that gusset plate. But you don't need to wait all the way to fabrication when the fabricator has all the threads and fasteners and welds modeled. So there's this intermediate step. So this would be another example. I've got images we'll show later of a roof drain riser coming down. I think the challenge there is you don't need to have fasteners, washers, and threads to start coordinating your drain riser drops. But you do need to have something more than just the early on 300 level column. If you're looking at penetrations through walls, you've got jam conditions that you want to look at. You might need those jams and light gauge metal studs that are hard to relocate over ribbon windows, doorways, large openings. Those have to be engineered. They're typically double layered, and you couldn't easily cut through them without causing trouble for other people. But you don't need every stud modeled. You could just use a lightweight model. These would be important things to dialogue. If someone's asking you to model plumbing content to a higher level of development, your first question is, well, are you getting everyone else's models at a comparable level? Because it doesn't do me any good to model all of my plumbing to a high level of development if everyone else is not doing it in a comparable fashion. there needs to be parity to do this process. Here's expanded view of the studs. So this just talked about, this is a generic Revit model. We had a project where we were actually doing Verandil openings for ductwork to fit in and then plumbing to run through, and we had to start looking at the actual web profiles. And so there is this tension between precision and accuracy. You can have a highly detailed model that looks very precise and is horribly inaccurate, like these bar joists. And if you're trying to weave your plumbing through it, you're really wasting a lot of time. And so one of the things that will greatly help the plumbing modeling is really knowing what you're going around and what you can rely on. So this would be a manufacturer's model where he had not received the joist fabricator information. So the steel fabricator models, he buys joists from a joist manufacturer. This is a placeholder he puts in early on. This tells me more about the project than this pretty picture one up top. Because this tells me he doesn't have the manufacturer's information yet. I know I can go below it, I just can't go through it. So the first time I see when I get a highly detailed manufactured product, whatever it is, curtain wall, trusses, light gauge studs, all these are things where a designer puts a specification and then typically a trade downstream fulfills the manufacturing of it. Bells and whistles go off. If people are asking you to coordinate your plumbing that you're modeling in around these things, you should start asking and digging into these questions. So you really need this model that has the actual web profiles, the bridging, and if you have heavy chilled water piping, they actually need to know where your hangers are going to go. I'm talking if you've got larger bore piping with notable weight. If it's over a few hundred pounds per hanger, they actually have to have these panel points connect at the hanger locations, and the manufacturer needs to design those in. So most of your plumbing and piping, not a problem, but be thinking about how you're going to work with the other individuals. But you don't need all their miscellaneous connector plates that go all the way to LOD 400. So big takeaway, and we're going to talk about civil here in a moment and how it ties into plumbing. As you approach and you get requests for your modeling, be asking what is everyone else is doing, and are we on a level playing field, and is it meeting a goal? How many of you are using laser scanning on your projects? Very good, excellent. This is an existing building, 1920s, and we were looking at coordinating the plumbing and HVAC and lighting around it. It's a theater, and they demoed the core of the theater and left this perimeter of stonework and one bay in. And there really were not any as-builts from the 20s. It is built-up steel structure. And what we approached in doing this was taking a laser scan, but this was the raw data. It was plate girders riveted with angles, and we were looking at, from our perspective, this was dense enough on high-end machines, we could actually start modeling plumbing, bring it into this laser scan model, and just use the cloud. We did not need to go to the extra step of modeling the structure from the laser. But our client, the general contractor, wanted it. So we started to look at a tool that would extrapolate the point cloud data, and then we would make massing elements. And then we'd look at how the plumbing would either connect and hang from the existing or pass through it. And yes? Okay. The question was, what tool did we use for this? And we used, the laser scanning in the field was done with a Faro Focus 3D. And then we used a collection of tools to do, CAD-based tools to do the extraction of the line work. And the request from the client was a Revit model as the deliverable. So the scan cloud was, we did very high density with color. And so we were approaching a gig per scan. And then the client wanted a lightweight Revit model they could do their coordination on. So I would submit to you the Revit model was actually a step back in the development of the truss. That truss in the Revit model, I would say, is 300. It's actually not as detailed as this 350, but this laser scan cloud, I can't really fabricate from it, so what do I call it? So there's not a good standard for how to define this and how to use it, but I would submit to you, if you're doing any plumbing in existing, you're going to see laser scanning on the rise. You know, is that fair what you're seeing on y'all's projects, more laser scanning? You're not comfortable with just running Clash on this? Right. We don't run the automated Clash on it, but it is more of a visual like you're talking about. And we will run it, if we're looking through pockets, we will try to see, is it hitting at all? Because you'll get some false positives. And so it is more of a visual layout. Very good point. So the question, his feedback was, he's using laser scanning. He's not comfortable with running Clash. It's more of just a visual walkthrough. Get it modeled, bring it in, and just get a first pass and look at it. So are y'all finding, from your perspective, are y'all actually then going in and modeling or requesting models be made from the scan? Yep. Okay. Okay. Very, very good. If I could, let me do one item real quick here. How many of you do need to leave? We're approaching the 30-minute mark and had scheduled. Okay, very good. We got about 5 minutes. I'm going to go through a couple items here that are content that I think is real important. Our firm is a multidisciplinary perspective. We have mechanical engineers on our team. Joe Powell is one who co-authored this with me. I'm a structural engineer. We take a distinct perspective when we look at construction site coordination. How many of you all know that this document exists? It's from the steel industry. It's open webs and steel beams. It's a guide. It's about 30 pages. Most structural engineers who are AISC members get it for free. And a lot of structural engineers don't tell you it's around. We've made Excel sheets in our team. Most, you've got a beam, steel beam. The flanges are there for the moment. I know this is a plumbing class, but give me just a second. The web is there for the shear. Well, the webs, just due to the nature of rolling, you typically only use maybe 30, 40% of the shear capacity of that beam. You might take out 50% of that beam web, and you're not going to hurt a thing if you don't have point loads along the beam. If you've got a uniform load on the beam, there's a lot of exceptions to these rules. Your structural engineer has to sign off on it. I'm not telling you should go cut beams like crazy, but it's not that difficult. You enter the parameters. Some structural engineers will have this as a typical detail. If you work in hospitals, this is on hospital projects, they're heavily congested. I'm going to submit to you, have a dialogue. This is one case study where we looked at moving the med gas just up into the line of the beams, getting it out of the way. Stiffened it, we moved out in one run. We just sleeved 12 beams, pulled out 112 fittings, 10 feet of pipe per 100 foot, and a very clean solution. And if it's caught early in the process and done in the shop, that's not an expensive add to the beam. Large bore chilled pipes, and this one run we added 4 sleeves, pulled out 40 fittings. Is it for everything? No. But it's a good question to ask if you've got things that you're thinking about. Long runs we've got a lot of one-line diagrams when we're working with, when we do the modeling for the plumbing contractor, we really have to, the first thing we do is for the longest run, and we start looking at it that's sloping and try to work back. And we find a lot of designers' models we get, at least for the most part, they're all flat runs, and they haven't worked out the slopes. And that's what's going to cause most of our problems early on. We've been on projects where the groups doing the large bore pipe didn't talk to the ones doing the duct work. 2 groups modeled simultaneously. They were looking at each other's models, but they added a bunch of fittings when they could have just moved some ductwork around in places. That experience really wins the day. Getting people that's seasoned and have built some projects and know where money is really spent. Is it in the labor? Is it in the material? How does all that fit together? Is going to help your plumbing projects. Get beyond just trying to use the tools and put stuff in there and get it to fit. Think through the project. I see a lot of gray hairs in the room, and y'all already know this, but we find a lot of times on projects will find very young people getting into modeling, and they'll run into this process of just trying to do stuff with the tools and not thinking through it. And they've modeled for weeks, and they've really modeled themselves into a corner. Because some did plan their schedules when this originally said 30 minutes, if there's things you can find we can improve on this, please send me an email. Take a moment, let me know. If you think we did do a good job, let Autodesk know. Fill out the speaker survey, and we can kind of go from there. I'm going to dive into some of the other content, but I'm going to take just a 5-minute break for those who did plan on the 30-minute length. Go on the way, have a good dinner, and have an excellent AU. I appreciate your time and attention. You sure? Thank you all very much. Okay. I'm going to repeat the question in a second. Go ahead. Just put it in as a placeholder. Just put it in. It's done. Okay. 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 Let me rephrase the question and make sure I answer it. Your question is, the pump is not going to change much. Why not just put in a family object early on that has a certain level of pumpness to it, and it's a placeholder, it takes up the space. That is... Yep. So let me rephrase your question and also make sure everyone understands. Dave Francis, you're Southland? Southland. Design build mechanical contractor. You're based in California? You're all over, but yep. David is also on the BIM Forum LOD working group with me. He chairs the part of the group that is on mechanical. And so David was, I'm going to repeat some of the feedback David provided, and just so it'll be recorded and everyone can hear it. And David, feel free to chime in if I don't capture everything. But you're saying that when y'all are modeling things early on in a project, you have to get drawings out and 2D documents out, and that you just model your ductwork, your plumbing, all at level 0 on the ground. One of the options. Mm-hmm. Mm-hmm. And then the allowance for what's a schematic 3D. The danger is every time, D- and I think his feedback is don't. We agree with you.
Right, but see, in other places, where you're saying that put all the stuff on the floor level, and then when you're on, some point, you can say, okay, well, this deck is going to be here. Seems to me like a waste of time of the user, of the engineer, put it on the floor and then lift it up and coordinate. I just attended our class, and people said coordination from day one, continue once a week. Because I'm going to wait and move my top off to the black level and do coordination, I'm going to end up having 1,000 clashes. Now I'm going to face a big mountain.
Let me repeat some of this dialogue here. So, and let me put a big ribbon around the whole thing. No two jobs are the same. No two teams are the same. No two delivery methods, because you've got different teams, are identical. Because you can have the same kind of contract, but if teams have not worked together, their tolerance for risk is very low, and they get their bells and whistles are going off, and they won't behave the same. And so, one idea is model early on for your 2D. Don't set all your elevations. The other idea is start coordination at the beginning from day one. What I'd submit to you is if the architecture and structure, there's this component of those two that are doing a dance early in design that has to get honed in. Your columns have to quit moving, and your floor-to-floors have to get honed in. One of the things I'm going to talk about is just the early definition of space, but until those two are honed in, I don't think it makes sense to try to dial in ductwork, plumbing, and electrical. You need to know the overall space you need, but it's hard to dial those in if your structure's still moving. Mm-hmm. Precedence. Uh-huh.
But that's just the design. So, in building, not every job is the same. Every job has those challenges, but there are certain elements we just consider non-negotiable structural and non-negotiable elements. Until that's finalized, you're still dancing around with it. Okay, so I might want to write the storm drains here, but all of a sudden they came back and okay, we had all this loads here. Also, the steel size changed. Weird things like that happen. But that's why it's called design. It's like I said, it's a dance.
Let me go to one hand in the back. Yes.
I personally disagree with the fact. I agree that it's cheaper to offset and relocate dock.
Okay.
I disagree that it should be done because adding whoever was on a dock for a dock system, mechanical system, can have far greater impact than adding whoever to make it fire.
And then give me a little background. What market are you working in? Mechanical and U.S. market, overseas market? U.S. market, okay. Right.
But the point I'm trying to make about the LOD is it's more in the graphic look and appearance than it's on the optics. A duct is going to be two lines, there's no graphic. A pipe is going to be two lines, there's no graphic. What they're talking here is more about the families. Why they make such a big deal with it? Why do I have to put it up as a box and then come down the road and change it to something else?
Yeah. What I will do is probably table this and move on, but I want to highlight that a model is just a cocktail of elements at different LODs, and if your firm wants to run it that way, all I'm saying is outline it in your BIM execution plan. This is what we're doing.
I don't mean to stretch it, talk about this, but LOD as a term has become like a hot cake, everyone wants to have a piece of it. And unfortunately, some people that have high level do not understand what that is. They force you and they choke it through your throat. Not
Yeah.
understanding what's going on here. So I'm trying to see why those people are trying to put back on the line, say LOD, and stuff like this.
Yeah. It is a paradigm change.
Engineers, typically our struggle is got to get something on Monday, got to get it out by Thursday. Well, what do you think you're going to get out by Thursday? Your product varies. I mean, we haven't seen views go up and the schedule has changed. Everyone wants to see the models, they want to see all the energy studies, all the other stuff come out of it. The plumbing, the same. We've got the same problem on all the industries. It's just, I think everyone's really seeing the struggle.
One of the things I found helpful in that whole LOD piece is getting people that have a lot of experience in design or construction, and I'm talking decades, a couple of decades, and can hone in and say, this type of building reminds me of one I did way back when. This is where we had all the coordination problems. It was in these areas. It was above the operating rooms. It was coming out of this congested mechanical area. It was the subgrade coming in through this part of the building. And then hone in and do higher levels of development and modeling in those and coordinate those spaces out early and try to find the biggest problems. Another thing I think is real important is that everyone on the team, when you're looking at trying to run the plumbing, you've defined coordinate systems for the project and everyone's using the same. When I look at spacing it, when I'm trying to coordinate plumbing, we only look at trying to coordinate one area, a plan at a time per meeting. We talked about this a little before. This is what we call a wedding cake. This is where we take a section through Revit early on and then just have a discussion with people on the team. And even if fire protection is not on board yet, we assume where are they going to go. And then when they do get on board, we have to ask where are their mains going to run. But we just use a product that we can take a screen capture and draw up these zones. And then we talk about where the large, like roof drains, are going to need to pass through. Starting where they're going to start high and where they need to slope from. And this sketch, before we dive into the models, saves hours and hours of time.
So you're saying specify vertical and horizontal spaces for each trade?
Get a rule of thumb for people to start working with. And then when you get into corridors that need to branch other directions, you're going to have basically two systems that have to always ride over each other. But get a typical understanding and don't let your plumbing modeler, your electrical modeler, your HVAC modeler just go start modeling. Do this and get it written down. We put this in a PowerPoint. We get everyone around a table. We show them. And then we take notes and edit this in the PowerPoint in front of everyone. And then we make a PDF of it and email it out. And we say, this is our game plan. Notify the team when you've got exceptions that you need to run this. It's a guideline. This is not written in stone. It's a quick guideline. It's a 2D sketch. Sometimes we'll do this on a whiteboard. We will project the Revit model, and we'll ask some of the seasoned members of the team, let's walk around. Where do you think are going to be the choke points on this job? Then we cut a section there, and we just take markers, and we draw up, okay, you're here, you're here, you're here, and we take a picture of it. These are very simple non-BIM things that can save many BIM hours. And in this market, I think, in this economy, we're going to have tight times ahead, I think. I hope not, but even if we don't, even if we have a lot of jobs flowing, we want to make as much profit as we can. This would be a case study of a designer's model I received, and all of the piping, I had valves floating, ductwork was running through it, and they had two different departments that created 2D documents. In their defense, that may have been what their scope was for. They may have been progressive and said, I really want to get into using Revit. I've heard good things about it. Structural and architecture like it. They want me to try. I'm going to go ahead and just try. I still got to deliver 2D documents, but let me try it. And then on this particular job, the owner heard they were using it. The contractor heard. Everyone said, we'll sign releases. Go ahead and share your models. And then when they did, this was an easy catch. I mean, and the owner did not understand this. The owner's question is, weren't you hired to provide a coordinated design? Well, yes. And is that coordinated? Well, let me explain. My fee didn't allow for me to go back and change all that. And so the owners don't really, they don't digest that well. It's basically like me being a chef and telling you, the chicken I'm serving you now has less salmonella than what I gave you yesterday. It's not a good sell. And so this is one of those areas where I could see perhaps, yeah, I'm not a restaurant, I don't have a restaurant. So, but, you know, what this is looking at is the profession, you know, if you're doing plumbing modeling, you need to start thinking about how you look with clients if you're in a multidiscipline firm that's doing HVAC and electrical. And what do you communicate if you're not doing the coordination to the architect, to the structural engineer, to the owner, to the contractor, if they see your models? And you need to outline very clearly what your deliverable is. That's where this LOD comes in important. But it might also be changing the standard of care. If I am the engineer of record on this system, can I really say that I've met the standard of care of what most mechanical engineer, what a standard average mechanical engineer would have done using good judgment? Well, I think that the day is coming when a number of engineers are using these tools where the average typical engineer using good judgment would not do this. And the thing with standard of care is we won't know when it changes until it's already changed. So this is something to be thinking of, and I see plumbing cropping up. I'll get feedback from any of you all who are designers, but I've had a couple of mechanical design firms tell me that my fee structure for ME and P is really 40%, 40%, and I get 20% for plumbing design. And plumbing piping is taking 50% of my modeling time. And so how am I going to go through and get to these higher levels of development? So that's a dialogue that that firm has to have. Does that ring true with any of y'all that are mechanical design firms? That typically your fee is 40, 40, 20. There's variations. But the plumbing might be 50% of your modeling effort. And so there's this, we're moving into a new deliverable. We've got old economies that still are out there. And so there's some education that has to go on with owners, architects, and contractors. So this is an example on that project, us rerouting the piping. You'll notice we've got higher level of development models on the steel.
Can we make assumption that you can make association between LOD with coordination of the model?
For this discussion here, but there's a lot more to it than that. Hold on to that thought. Right. Uh-huh. It can take a lot of time. And you know, I think these are all real important things as you define your scope on your project, your fee, your schedule, because it really affects all of those. This is a roof drain riser. The plumbing model originally had there, the structural engineer didn't have the base plates modeled. Now, could the plumbing modeler have known that there's structure there? Yes, he probably should have. But it wasn't modeled. When the fabrication model came in, it's clear something that had to go on. And so when it looked at moving that roof drain out to miss the structure, then you had to move the fur outs. And so these are common areas. I mean, a lot of jobs when we get firms that are, when we're working construction side and we get firms that are new to modeling, this is a very frequent one, roof drain, fur outs, things like that. Entry areas. These entry drive ports like outside buildings are probably the last thing to get designed because it's, you know, it's gingerbread dressing. You know, it's the icing on the side of the gingerbread house, and no one thinks about that. And these are coordination areas that can affect plumbing. Frequently, we'll see the drains on these get as an afterthought. A lot of times we'll get designer models where maybe they coordinated with structure, but then it was very clear the plumbing department didn't talk to the HVAC department. And they missed structure. Everyone looked at structure. Each department looked at structure, but they didn't look within their own firm. And so they leave it to the trades to go through and then just move things around. Is this a big deal? Well, a lot of times not, but it doesn't look good. And so you have to think about scope and what your firm looks like to others. These are showers in a hospital. Couldn't really move the risers and drains, and just coordinating with how the duct needs to function there. When we do plumbing jobs, we have a very well-defined naming convention for the files we export out, and this has helped us. We use Navisworks Manage to run coordination, and we have a naming definition that defines the project, the type of model it is, and we have an outline that shows all the different disciplines, and then the levels, and then the end of it is a specific naming convention that says the percentage complete of that model. So this one's 50% complete, and it shows a date. When we look at that, or we have one tool we use. This is a free tool called File Renamer, and we set up our Navisworks Manage. How many of you are doing plumbing or using Navisworks Manage with it? Okay, and y'all are doing the projects where you have one source batch of file names and you're not renaming them? Okay, yeah. So that's kind of the standard way you want to do it. And so we use File Renamer to strip them off, and so the clashes will auto-detect. Apologize about that. So File Renamer, we basically get everyone's files, and then we use Renamer to strip off the back and then drop them in the Navisworks folder. There's another product called Digital Exchange Server, which, how many of y'all have used this product? It's a web-based tool. If you want to use that workflow with Navisworks, this is a web-based tool that supports that. In the handouts, we'll have information that shows that, where you can learn more about that. To do any kind of plumbing coordination, you need a good structural model that includes this trade information. So these are cold form metal studs. In design, the structural engineer provides a specification. However, to do that cross-trade coordination, you need things like these kickers modeled, and they're not available at design level. This is a project where the risers need to be defined, and the design level model didn't show that. It just showed the stud rails. But when you really dig into it, you've got tendons and mild steel there, and you don't have enough room to really fit your risers in, your sleeves. This would be a tactical application of laser scanning, and we were doing a mixed level retail building, and this one was in El Paso, multi-level garage with retail above, and needed a lot of sleeving for the plumbing, drains, and then also risers. And all of these PT cables are provided by the trade contractor. The structural engineer doesn't show those cables. They give a note and they say how much stressing needs to be applied. And so we were advocating to facilitate future use of plumbing and piping installation and electrical for other tenants that may happen down the road. Let's laser scan before each pour. And in doing that, we would then have a map of each of these tendons that have not been previously modeled. And so we were thinking 5 years down the road, you'll switch tenants in one of these areas, maybe add a restaurant in, they'll need some sleeves put in. And we went through and did laser scanning on it. So before each pour, we fly out, sometimes the day before, 2 days before the pour, so that we're there the day before the pour. If it's a late, early morning pour, we'll go in that same day and laser scan the tendons. And this was for future use, and then we found that some of the trades missed putting their sleeves in at the pour. So This was 4 years down the, this was planned for years down the road, and we're actually using it this week, actually, to go back and core fresh concrete. But this would be a very powerful tool if you have facility owners with long-term. So if you're a building owner, a university, you might want to try to work this into your requirements. If you're a general contractor and you have long-term clients that you want to service, you might start to look at this. Structural model, it's not good enough just to have the concrete. A lot of areas with expansive clays, you need the void boxes modeled. And so if you're going to really do a detailed coordination with plumbing, you need those carton-formed void boxes. Do any of y'all work in markets that have expansive clays? Get one here. So in our region, we have some parts of the Dallas Metroplex area that will get up to 10 to 12 inches of vertical rise. I mean, think about that. Your plumbing is going to basically rip out if you've rigidly gone into a grade beam. Easily, you're going to get 2 to 3 inches of vertical rise in a lot of parts of the North Texas region. Now, that's a soil expansion. And so the geotechnical engineers in our market will tell the structural engineer, you need to provide cardboard, wax-covered carton forms for 8, 10, or 12 inches so that after the concrete is poured, the boxes deteriorate, it leaves a void space underneath it. So if you're working in a region that has that and you're running your plumbing, the geotech will not let you put your pipes right under that grade beam because when the soil heaves, you're going to rupture your lines. And so we find this a lot with designers or trades that come in from other markets that don't have expansive soils. And so this is something to think about. A quick and expeditious way to do this, if your structural engineer hasn't modeled this and you're working in a region of the country that has expansives, is go into Navis and just drop the structure that length and then run your coordination. If you're going through the beam, make sure you've added enough sleeve distance around the mid-height of the beam so your plumbing lines can float. In this case, when you're in markets like this, that second floor is just like a whole nother floor of the building. And it's like your first floor is like a second floor and you've got a ceiling height of 10 inches. You put carton forms under the entire slab and the concrete, and then you need to design your plumbing so that it floats beneath that. And then you have to work in expansion details anywhere the plumbing comes in and connects to the structure. Other areas to think about when you're dealing with this kind of coordination would be, how many of y'all have worked on hospitals in California? Some of them have base isolators. I worked on Mills Peninsula in 2006. We were doing the coordination on that. At maximum drift, there was 21 inches of movement of the 6-story hospital on the base isolator. And you had to look at how your plumbing was coming out of the soil, connecting to the structure to tolerate these movements, because the hospital has to stay operational after the event. And so base isolators, bells and whistles should start coming off anywhere your plumbing is coming from the ground into this, because now you're connecting to a moving machine. Coming 5 feet out of the building, the civil, how many of you are working on plumbing jobs where you're civil engineers in Civil 3D? One there, one there. Very good. What we like to do early on, civil has a different perspective of tolerance. Sometimes I think for the utility contractors, if it's the nearest foot, they're happy. And so I look at early on getting those civil subgrade utilities, make sure their invert elevations are lower than the plumbing coming out, and just make sure that we've thought about it. It's typically more economical for the plumbing to go below the concrete beams than through them, unless you've got hill conditions. But most general contractors would prefer the plumbing not to be sleeved through the rebar. Are there any GCs in the room? Is that a fair assessment? That's my perspective from my structural background. Joseph Powell's not here with me. You know, we have dialogues from it. He's the mechanical engineering background. it's just easier that way, but you're also increasing the amount of excavation the lower that line goes. So if you've got really long lines, you might start going through the structure, but then you've got to provide room for movement. The civil utilities, it's helpful to at least get them to come up and make sure they're at least lower. And then the plumbing, as it's coming up, you can always dive down and tie into it. You just don't want, obviously, the civil inverts to be higher. So these are something that I think there's a lot of value if you're getting requests on design side to provide higher detailed plumbing models. Be sure to ask. We also want that civil model. The civil engineer should write an action recorder that will do 4 movements on that civil file. They should move a Z rotation, and they should move the X, Y, and Z translations so that that civil file utilities are delivered on the project's coordinate. We talked about setting up project coordinates. I prefer to do all plumbing coordination on a local project coordinate and not true north. The whole design team around plumbing is thinking true north. I've seen a lot of mess when people try to do the coordination on state plane. And we can talk about that in the Q&A if people have different perspectives on that. Bringing in the surfaces is very helpful in looking at where overflow drains are going to come out the building and how those are going to tie together. We use Navisworks typically for this, bringing in the civil 3D part. It's kind of clunky to bring in the civil infrastructure and utilities into Revit to do utility coordination with plumbing. So that's where Navis within our firm comes in. We've talked about this one. Talking about families, obviously there's going to be a lot of opinions about this. We've talked about a good bit under the LOD. We had a family discussion up here. You basically want to think think about where your connections are shown, and if it's a manufactured object that you're connecting plumbing up to, just make sure that you're not trying to model something at a high level of detail that's not the actual final product. We've got projects where the mechanical piping VAV boxes were modeled in the design level, and they routed all the piping up to it and connected to it. And the box that was actually delivered on spec on the job had the taps coming off the other side. All of that effort in modeling the piping and coordinating around it was just trash. And it created a lot of coordination problems. We had areas where things wouldn't really fit together because now the piping was going through ductwork that was already in tight areas. So when you think about these family objects, make sure you get everyone's input. Don't just download a manufacturer's product and think that's what will end up on your job. Excellent. Okay. How many of you are using SwitchBack? Got one right there. If you're in Revit, I'd strongly recommend adding Navisworks Manage to your process. Navisworks, it's not a hard tool to pick up and integrate into your team, but Revit now supports SwitchBack. Essentially, you can have a clash or a conflict in Navisworks you can walk up to, and SwitchBack will zoom Revit into where that conflict is. Yes. I think it would work with Simulate. Yeah, so Simulate does not have clash detection, and so if you were just doing a walkthrough and you found some stuff manually walking through it. But your question was, do you need Navisworks Manage to use SwitchBack? It is a good point. And so we found it to be a very helpful tool with plumbing, especially when we're working out gravity lines. We'll walk down the lines, hit conflicts, and go back. I quickly ran through beam penetrations earlier. How many of y'all have been told by your teams that we can't penetrate steel? We have to leave the structure alone. Okay, and I hear that a lot. It's a good attitude. It's a good philosophy. When you get into particularly hospitals or when I can see this adding a lot of value. And so you might ask them, I'm not a structural engineer, but I was kind of noticing American Institute of Steel Construction Design Guide 2 is all about web openings. What's that about? Could we maybe cut a little opening here and clear up some space. So here's what I think of when I think about penetrating steel. I want to look for typically pressure systems that are flat. I like to have my openings so they're repetitive, because the engineer does need to design the solution. And I like to have it where if I'm not the structural engineer record and I'm working construction side, I will basically write this up as an RFI and we'll give them a mock-up like this. And we've actually run the engineering calcs and we know this works before we send the RFI through. But I try to make it very easy for the structural engineer in that I try to pick a path. Is there one system I can move up? On a concrete parking garage, I try to move fire protection and electrical up. Owners like to have very clean garages, so gravity piping is hard. Your drains in a garage, they're hard to move up into structure. But any of your pressure lines, we've got a garage with this retail on top. We've done RFIs where we looked at creating openings, block-out openings to run all the pressure piping up in through the structure. Med gas, this is another good candidate for this kind of work. It's not every application. I'm not saying this is every solution for every problem. It is something good to know. It can be done. It's not that hard. And you want to just be logical. If you can pick one system down a congested corridor, move it up into structure, and clean the corridor, and you're only doing a handful of openings, I would throw it on the table. It's a viable option. We talked about long runs. We talked about the fittings. That got into a good discussion. What I'm going to do right now is, as we're wrapping up this, I want to open it up to Q&A. But like I said, if y'all have been a very good audience, if there's things I can do better, definitely let me know. And if you think we did do a good job, please give us a good rating on the AU speaker evaluations. We really look forward to that. Joseph Powell, who was unable to be with me here today, did a lot of work in this. And so most of the good stuff you see in here, he had his handiwork in. I'd like him to get some good recognition for that. But let me open it up to Q&A. Are there any questions about what we talked about?